Hi, Mr. Richards here, and today's lesson is on simple and compound interest. We're getting into some banking concepts today, both in loans from the bank and credit cards, and even when you put money into savings accounts or even checking accounts that earn interest. So this is definitely a lesson for real life. Well, let's get some key definitions first. And the first definition we need to talk about is interest. Interest is the amount of money paid or earned for the use of money by a bank or other financial institution. Our other key word here is principal. And principal is the amount of money invested or borrowed So there is a key formula here that we're going to use, and that is I equals P R T. Now I is interest. P is principal. R is an annual interest rate. And remember, annual is yearly. And T is your time, typically in years. So we have I equals PRT, and we're going to be using this type of formula on many of the questions you're going to solve today. Now, there's one more definition to talk about here, and that is the definition of simple interest. And simple interest is paid only on the initial principal of a savings account or loan. For example, if you put $100 into a bank and you earn interest on it, the only interest you're going to earn is on that $100. It's not going to say earn you $5 interest over a year and then the next year calculate money based on that $105. It's only considering the $100. So on our first example, we want to find the simple interest to the nearest cent. So I'll have $2,000 at 2.5% for 3 years. Well, if we start off with our key variables, we'll have I for interest, P for principal, R for rate, and T for time. We're looking for the simple interest, so we're just going to say that I is, well, I. Our principal is going to be $2,000. Our rate is 2.5%, but we have to get that rate into a decimal, or at least decimal form. There already is a decimal there. And in decimal form, that's going to be decimal point 025. Remember, you have to move your decimal place over once and twice. And time, well, we have 3 years, and that t value needs to be in years, so we're good to go. Now, rewrite your formula. I equals PRT. You're solving for I, so we can keep the I. That's going to equal our principal of $2,000 multiplied by our rate, which is 0.025, multiplied by our 3 years. And once I multiply those 3 numbers together, I get 150. No need to round to the nearest cent here. I'm just in simple dollars, so $150 is my answer. So one of the keys here, check to make sure your time is in years, then it is, and get your percentage into a decimal form. Our next example is $4,500 at 4 25/100% interest for 2 years. So again, if I start off by looking for my variables in our formula, I'm once again solving for interest, so I can stay I. My principal is $4,500. My rate is 4 1/4%, or 4 25/100%. Now, in decimal form, that's going to be 0.0425. Don't round anything there yet. You're going to move that over twice. You have to have that 0 there to the left of the 4. Our time is 2 years, so we're good there. As you go to write your formula, I equals PRT. Start every question with the formula. Then our interest, I, is going to equal our principal of $4,500 multiplied by our interest rate at 0.0425 multiplied by our time in years is 2. And once I multiply those together, I get 382 decimal point 5, so 5/10. But to keep this answer in money, since that's what we're dealing with, this is $382.50. Now one more question here, $2,345 at 6 7/10% for 8 months. And yes, it does go 2, 3, 4, 5, 6, 7, 8. So creative. Now, we're looking for our interest again, so I is going to stay I. My principal is $2,345. My interest rate as a decimal, well, it starts off 6.7%, but that's actually 0.067. And my time is 8, except it's 8 months. And this time value has to be in years. So how can I express 8 months in years? Well, do so with a fraction. 8 months is 8 months out of 12 that are in a year. So once I simplify that fraction, divide by 4 on top and bottom, I get 2/3. So 8 months is 2/3 of a year. Very important to recognize that this is months and not years, and the t we put into this formula has to be in years. So, speaking of the formula, I have I equals PRT. I is going to equal my principal of $2,345 multiplied by my interest rate of 0.067 multiplied by my time, which is 2/3. Once I multiply these all together, my interest is going to equal $104, decimal point 743. Now I do need to round this to the nearest cent. And the cent here is the 4. And if I look one to the right, the 3 is not going to round the 4 up. So my final answer here is $104.74. So the key out of this question is to make sure your time is in years. And 8 months is 2/3 of a year. Now we can also use our simple interest formula to calculate an interest rate. Mr. Webster borrowed $1,280 to buy a new swimming pool. He will pay $57.60 each month for the next 24 months. Find the simple interest rate for his loan. Well, once again, we can start off by going, okay, I equals, P equals, R equals, and T equals. And we'll again use our formula eventually, I equals P RT. But instead of solving for I, we'll solve for R, the interest rate. But before we can do that, we need to figure out the amount of interest that Mr. Webster will pay. Now we're being told that he's paying $57.60 every month for 24 months. So if I multiply those two numbers together, $57.60 times 24 months, that is $1,382.40. Now he borrowed $1,280 and he paid $1,382.40. So if I take that $1,382.40 and subtract the amount he borrowed, $1,280, I would get $102.40. Now that amount of money represents the amount of interest he paid. That's the amount extra. That's the amount of money he had to pay in order to borrow the money. So the I interest is going to be $102.40. The amount he borrowed was $1,280. The interest rate is what we're looking for, so that's R. And the time we're given in the question is 24 months. But 24 months into years, we take 24 over 12 and we get 2 years. So now we have all the information we need. We can put $102.40 in for the I. We borrowed $1,280. We're looking for the rate, and our time is 2 years. Be careful not to put that 24 months in. It has to be in years, so 2 years. Now, we can use the commutative property of multiplication to actually multiply the 1,280 and the 2. And when we do that, we get 2,560 times R. Now to finish this question, divide by 2,560 on both sides. And the result is 0.04 equals R. And as a percentage, with the decimal place back over twice to the right, and that is 4%. So he had a 4% simple interest rate for his loan. So if we go back and take a look at what we did, he borrowed $1,280, and that was our principal. He paid $57.60 for 24 months. So his total payments came to $1,382.40. But we needed to figure out how much in interest he actually paid. So he took $1,382.40 and subtracted the amount that he borrowed to get $102.40. That was our interest. So once we knew our interest, our principal, and our time in years, we put those three numbers into the formula and solved for our unknown, which was the rate. We used the commutative property of multiplication to get to our 2,560, which we ultimately divided, to get our 4%. But wait, there's more. We have compound interest. We just talked about simple interest. Now we have compound interest. Now, compound interest, the definition of this is interest paid on the initial principal and on interest earned in the past. So it's just a little bit more complicated. We have to take year to year into consideration now. What is the total amount of money in an account where $800 is invested at an interest rate of 6 25/100% or 6 1/4% compounded annually for 2 years? Now, compound interest, remember, is paid on the initial principal and on interest earned in the past. So we're going to have to calculate this year by year. So our first step, step 1, is going to be to find the amount of money in the account at the end of year 1. Okay, well, we're going to use our same formula, so we can still look at our interest, our principal, our rate, and our time. The interest we're looking for, that's I. We put in $800 for a principal. Our interest rate was 6.25%, which as a decimal is 0.0625 or 0.0625. And our time here is not going to be 2. It's going to be 1 because we're looking for just the end of the first year. So if we look at our formula, I equals PRT, our interest is going to be the $800 times our interest rate, 0.0625, times our 1 year. When I multiply those together, I have $50 in interest. So if I started with $800, after 1 year, I earned $50 more. So in the account, I have $850 after that first year. Now, I'm going to use that $850 in my next part of the problem. Step 2 is going to be to find amount of money in account at the end of year 2. And I'll still have my new interest, but that's still going to be I. My principal now is not $800. It's $850. My interest rate still remains the same at 0.0625. And my time is still, it's just 1 year. I know we're into the second year now, but the amount of time, the $850 is going to be at 6 25/100% is just 1 year. So I can take my I equals PRT. My interest is going to equal my principal of $850 multiplied by our interest rate multiplied by our amount of time. When I multiply those together, my resulting interest is $53 and 12.5% cents. Now keep that, believe it or not, until after we add this. So we started the year at $850. We add our $53 and 12.5 cents. And our result is $903 and 12.5 cents. Now, let's go ahead and round this to the nearest cent. That's why we did not want to just drop the 5. Let's round this to the nearest cent. And that's going to be $903.13, since the 5 will round the 2 up to 3. And that's our final answer. So the biggest difference between compound interest and simple interest is the compound interest, since we're compounding it, we're adding the interest back in every year, we have to calculate for each year the amount of interest earned. So you can see the first year we earned $50 interest. We put that money back into the principal. Then we earned $53.12 interest. So just after 1 year, we earned $3 more in interest. And that's where savings really comes in handy, because if you just keep money in the bank and the interest compounds annually or sometimes monthly or some accounts, if you're lucky, daily, that little amount of money you invest early on can become a lot of money later in life. That's it for this lesson. Good luck.